This tutorial will demonstrate how to test hypothesis, which refers to the second form of generalization according to the textbook. Although almost everything we do on a population level involves testing hypotheses, in the textbook in particular they refer to hypothesis test to three particular forms of comparison. It is when we compare a population parameter, which can be a mean or average, to a number, if it is equal to a number, if it is greater than a number, or if it is less than a number. In Excel data analyst, hypothesis tests can be performed for both averages and percents, or in other words, for metric and categorical variables. SPSS, however, can perform hypothesis test only for metric variables or averages. SPSS cannot perform hypothesis test for proportions. It's another story why they decided to choose so, but this is a fact. Also, in Excel data analyst, they have different notations. They call hypothesis test hypothesis tests, but actually those hypotheses have specific statistical names. And I recommend you to remember those statistical names for our future classes because we'll be covering other tests. In particular, hypothesis test, the actual statistical name of hypothesis test is called one sample t-test. So one sample t-test is used when we compare a population mean to a number. It's called one sample t-test. The other tests we'll be covering in future chapters, but this time we cover only on one sample t-test. So the A concepts data file is already prepped. It's entered into SPSS along with the labels of the variables for easy reading. And let's test some hypotheses. We tested several hypotheses in Excel data analyst and during the practice, and I'm going to repeat pretty much the same hypothesis tests in SPSS. So let's say I want to compare I want to check if the number of people in household is equal to 3. This is the hypothesis which I want to test. To do so, I need one sample t-test, which in Excel data, which in SPSS is under compare means one sample t-test. I select number of people in household and I compare it to the number 3. That's all. I'm not going to discuss what involves in options. Actually, here is where we can change the confidence level of our test, which is something we cannot do when using Excel data analyst. So let's click OK and see what happens. SPSS, the output of this hypothesis involves two tables. The first table lists the name of the variable, how many observations are available, and its average. So this is the information coming from the sample. Average for the particular sample is 2.2. And this is the table which provides output based on the hypothesis which was tested. At the beginning of the sample, at the table, we see that it's titled one sample t-test. And the test value, or the value to which we compare the population mean, is 3. So where is the significance level which is used as a trigger to reject or not the null hypothesis? It is here. And SPSS reminds you that this is a two-tailed test. The significance level is 0, which is below 0.05, which means we reject the null hypothesis of the mean being equal to 3. Which means the mean is not equal to 3. Another way to say it is that we are 95% sure that the number of people in household is not equal to 3. So if it is not equal to 3, is it greater than 3 or less than 3? Well, we see that the average for the sample is 2.2, which indicates that it is less than 3. So we can say that the number of people in household is less than 3. Again, the later conclusion is a directional hypothesis, and I'm using the result from a two-tailed test, which is a non-directional hypothesis, to make this conclusion. But for practical purposes, making those conclusions is perfectly fine. From a statistical perspective, it is not the best way to approach it, but again, from a practical perspective, it's perfectly fine. So I can say for practical reasons that the number of people in a household is less than 3. Let's test another hypothesis. Now, before we tested the probability, we compared the probability of a standard size electric auto within 3 years to 30. So let's repeat the same test. I'm going to the shortcut here, select one sample t-test, and select the probability of buying electric auto within 3 years. A standard size electric auto within 3 years. And I want to compare if it is equal to 30, because this is the number we used in the other examples and during our practice session. Click OK. And again, the first table tells us that the probability of buying a standard size electric auto within 3 years has 1000 observations, and within the sample the mean is 34.64. In our one sample t-test table, we see that the value to which the population mean was compared is 30. The significance level is less than 0.05, which rejects the null hypothesis for the population mean being equal to 30. So with this number, with this result, we are 95% sure that the population mean for this proportion is significantly different from 30. Well, if it is different from 30, what is it? Is it greater than or less than? We look at the sample mean, which indicates that it is greater than 30. Again, this conclusion is not the absolutely precise statistical way to say it, but for practical reasons, it's perfectly fine. It is widely used. So we can conclude that the probability of buying a standard size electric auto within 3 years is greater than 30. This is how we calculate, this is how we test hypothesis in SPSS using one sample t-test with just by looking into the significance level and the sample mean. It's more than enough to make a conclusion about the direction of the relationship. And I'm going to conclude by repeating that SPSS tests hypothesis or one sample t-test only for averages, for metric variable. It doesn't do it for categorical or variables or percentages.